Hello everyone, and welcome back to the Microscopes and Magnification series. I'm here to help you master calculating orders of magnitude and stop losing marks. If you're not comfortable with using standard form, you may want to check out my video linked below before watching this one. Let's dive right in. By the end of this video, you should be able to define what order of magnitude means, calculate orders of magnitude between different values, and apply orders of magnitude to compare microscopic units. So what exactly is order of magnitude? Think of it as biology's shortcut for comparing sizes. Instead of saying this cell is 5,327 times bigger than that one, which is long and confusing, we use orders of magnitude. It's a simpler way to compare the sizes of cells and objects by using powers of 10. Here's the key idea. Each order of magnitude represents a tenfold difference in size between two objects. So let me show you what that looks like. 1 order of magnitude equals 10 to the power of 1, which is simply 10 times bigger. 2 orders of magnitude equals 10 squared, that's 10 times 10, so 100 times bigger. 3 orders of magnitude equals 10 cubed, so that's 10 times 10 times 10, so 1,000 times bigger. 4 orders of magnitude, that's 10 to the power of 4, so 10,000 times bigger. And 5 orders of magnitude equals 10 to the power of 5, which is 100,000 times bigger. You can see the pattern, right? Each time we add 1 order of magnitude, we're multiplying by another factor of 10. Now here's where it gets interesting and where the exam marks are won or lost. Let's calculate our first order of magnitude together. Here's a real exam style question. A red blood cell is approximately 7 micrometers. A bacterium is approximately 1 micrometer. How many orders of magnitude bigger is a red blood cell than a bacterium? Here's the 3-step method you need to beat this question. Step 1. Calculate how many times larger the red blood cell is compared to the bacterium. We do 7 divided by 1, which equals to 7 times bigger. Step 2. Round to the nearest power of 10. Now 7 is closer to 10 than it is to 1, so we round 7 to 10. Step 3 is to convert to orders of magnitude. 10 times bigger is equal to 1 order of magnitude. And that's it. The red blood cell is 1 order of magnitude bigger than the bacterium. 3 simple steps and you've got your answer. Now let's step this up. What if the question gives you numbers in standard form? Don't panic. There's actually an easier method for this. Let's look at this question. The diameter of a human cheek cell is 6 times 10 to the minus 5 meters, and the diameter of its nucleus is 6 times 10 to the power of minus 6 meters. In orders of magnitude, calculate how many times larger is the cheek cell compared to its own nucleus. When we're working with standard form, here's your shortcut. Step 1. Identify the powers of 10. Ignore the 6 completely. We only care about the powers of 10 when finding orders of magnitude. The cheek cell is 10 to the power of negative 5 and the nucleus is 10 to the power of negative 6. Step 2. Find the difference between the powers of 10. The difference between negative 6 and negative 5 is 1, so we get 10 to the power of 1 as the difference. Step 3. Convert to orders of magnitude. A difference of 1 power of 10 means 10 times bigger, which is 1 order of magnitude. See how much faster that was? When you spot standard form in the exam, use this method and it will save you time and reduce your chances of making mistakes. Right, let's lock this in your memory. Here's a table you may find extremely useful for your exam, and the good news is it's just a pattern. Can you guess the missing values of the table as we go? 1 order of magnitude equals 10 to the power of 1, which is 10 times bigger. 2 orders of magnitude equals 10 squared, which is 100 times bigger. 3 orders of magnitude equals 10 cubed, which is 1,000 times bigger. 4 orders of magnitude equals 10 to the power 4, which is 10,000 times bigger. And 5 orders of magnitude equals 10 to the power 5, which is 100,000 times bigger. Now let's put this into practice with some real exam style questions. Here's a classic exam question. A typical virus has a diameter of 2 times 10 to the minus 8 meters, while a human cheek cell has a diameter of 6 times 10 to the minus 5 meters. Calculate how many times larger the cheek cell is compared to the virus in orders of magnitude. Okay, standard form again, so we use the shortcut method. Step 1. Identify the powers of 10. The virus is 10 to the minus 8 meters and the cheek cell is 10 to the minus 5 meters. Step 2. Find the difference between the powers. We find the difference between 10 to the minus 8 and 10 to the minus 5, and that gives us a difference of 3, which means 10 to the power of 3. Wait, why is it 10 to the power of 3 and not negative 3? It's because when we subtract from a negative value, the answer becomes positive. Step 3, convert this to orders of magnitude. 10 to the power of 3 equals 3 orders of magnitude, which means that the cheek cell is 10 times 10 times 10, or 1,000 times bigger than the virus. And you've just gained 2 marks in your exam. One more guided practice before you try solo. Ready? The question reads, a typical human cell has a diameter of about 120 micrometers, while a virus has a diameter of about 0.02 micrometers. Calculate how many times larger the egg cell is compared to the virus in orders of magnitude. Notice no standard form this time, so we use method 1. Step 1. Calculate how many times larger the egg cell is than the virus. We do 120 divided by 0.02, which equals to 6,000 times bigger. Big difference, right? Step 2, round to the nearest power of 10. Is 6,000 closer to 1,000 or 10,000? It's closer to 10,000, so we round to 10,000. Step 3, convert to orders of magnitude. 10,000 is equal to 10 to the power of 4, which is 10 times 10 times 10 times 10, or what we call 4 orders of magnitude. So the egg cell is 4 orders of magnitude larger than the virus. See? 2 different methods, same logical process. All right, your turn. I've got 2 exam style questions for you. Question 1. A typical chloroplast has a length of 5 times 10 to the minus 6 meters, while a virus has a diameter of 2 times 10 to the minus 8 meters. State the difference in orders of magnitude between the two. This is worth 2 marks. Question 2. A typical plant cell has a diameter of about 100 micrometers, while a ribosome has a diameter of about 0.02 micrometers. Calculate how many times larger the plant cell is compared to the ribosome in orders of magnitude. Also worth 2 marks. Pause the video now and have a go. Press play when you're ready to reveal the answers. Welcome back. Let's mark your work. For question 1, the chloroplast is 5 times 10 to the minus 6 meters and the virus is 2 times 10 to the minus 8 meters. We find the difference between the powers. 10 to the minus 8 minus 10 to the minus 6 equals 10 to the power of 2. 10 to the power of 2 equals 2 orders of magnitude, which means 100 times bigger. If you got that right, brilliant. That's 2 marks secured. For question 2, the plant cell is 100 micrometers and the ribosome is 0.02 micrometers. First, calculate how many times larger the plant cell is. 100 divided by 0.02 equals 5,000 times bigger. Next, round to the nearest power of 10. 5,000 rounds to 10,000. Afterwards, convert to orders of magnitude. 10,000 equals 10 to the power 4, which is 4 orders of magnitude. Another 2 marks secured. How did you do? Here's the thing, examiners love these questions because they test both your biology knowledge and your math skills. So practice these until they're second nature. If the examiner wants to make it more challenging, they may also ask you to convert between units like micrometers and nanometers. See my video on converting units linked below if you'd like to learn that skill. You can also get more practice questions free from the Tutorism, Microscopes and Magnification workbook. See details in the description. Right, well done. Let's recap what you've mastered. You can define what order of magnitude means. It's a way to compare sizes using powers of 10. You can calculate orders of magnitude between different values using 2 different methods, one for normal numbers and one for standard form. And you can apply orders of magnitude to compare microscopic units like cells, viruses, and organelles. These are easy marks in your exam if you know the method, and now you know the method. If you found this video helpful, click that thumbs up button and subscribe for more GCSE Biology content, and check out the rest of the Microscopes and Magnification series. See you next time.